talk about building a modern data discovery BI platform using Apache Spark and Catalyst, right? So why we're all here. You have to sign your disclosure agreements because, Workday is a public company. So nothing I say can be held against me in a court of law. So I'm going to first talk about what was Platfora. What was this thing that we created? And we called ourselves Big Data Discovery, and we said that involves a bunch of critical components. What do you need to have to be doing, if you're doing Big Data Discovery, what is it? And it starts with interactive data preparation, so you're taking raw data in, data that's typically landing into Hadoop, and you have to be able to easily and quickly prepare that data and to make it useful for analytics. You have to be able to take that data into a tool for interactive data exploration, so visual analytics and BI. You want to be able to start enriching that data with behavioral analytics and segmentation and other kinds of advanced analytics that you throw into that to start to understand that data a lot more deeply. And from there, a few other pieces I think are really important. Quick iteration. So you're going to bring in some data. You're going to explore that data for a little while. Usually, the answer to a question is 5 more questions. So you want to bring in some more data and enrich your experience and dig down into some space and explore some more. So the tool should be able to do quick iteration. Enterprise ready, so everything that we sold was to enterprises, and it has to have strong security. It has to have a place where you can find all your data catalog, permissions and lineage to track where this data is coming from, where it goes to. And the tool should be nicely collaborative. You have a team of different people with very different skills. You want to leverage them and be able to pass pieces of the solution from one person to another, as well as to share the insights that you made off to other people. So it's sort of our motivating, what we tried to build. So that's what we think we were building, an agile, iterative, modern BI platform. So this was one of our sales things. I have a bunch of sales decks, and I'm going to drop into a whole bunch of technical stuff in a few more slides. So, but this all really helps set the stage, I think. So what was Platfora? It had this interactive data prep. I'll show you a demo in just a minute, where you bring in your data and explore it. You then were able to go off to what we called viz boards, where you could make these visualizations with drag and drop queries interactively running and coming out. Add some behavioral analytics. You can go back and add more data, right? That's the iterative part of that whole thing. So let's do a quick demo. And I said this is a demo of the last software that I'll ever sell for you to take home. Go cloud. That's the new answer. So this is the data catalog of Platfora. This is what you come in when you first log in. You say, well, what data do you have? So you're able to come in here, do searching for the data. You can organize it. Each of these cards represents a data set, which is a table of information. And so you can come in and you can maybe look at one. Let's go look at one of mine. Let's look at this GDELT data. So there's this project out there. You can get a bunch of public data for it. It's kind of interesting. They're taking all of the news media and they're extracting actors and actions and trying to categorize news stories about who and what's going on out there in the world. So I pull a little bit of that data, and that's what I'm using for this demo. So that's what this data is. It has actions and locations and actors, who are the people that are doing stuff. And so you can go see the schema of it, see some descriptions, which of course I didn't fill in. You can look at the data. This is a relatively low-res view. Let's do that a little bit. It's a little Greek for people in the back, but you get to see more. So the tool is generally designed for a fairly big screen. So here you're seeing example data from the data set, right? It's right now live going. If I had just loaded that data, you'd be able to see it by looking at just the top of the files. Showing you some data, showing you that, yes, you're indeed parsing this data correctly. It's looking okay. You can see information about it, see the distributions over here on the side. It's a long, here are the top values of that column. Let's look at something more interesting maybe. No, that won't be interesting either. There. So here's the distribution of the actor name. United States is coming up top within our little sample. We're only looking at 100 rows. We can instead bring that up to 1,000 rows, 10,000 rows, 1,000,000 rows. and then you're going to bring in more of the data into the browser and be able to take a look at it. It's just to make sure that things are looking right? Inside of here, you can start to edit this thing, so you can add computed columns. I did a couple over here. We're able to parse our date. This one's kind of a fun one. So does the URL contain the word Trump in it? So does the headline of the news article talk about Trump? We're going to have a little indicator that says, yeah, this is an article about Trump. Okay. So that's this data. You can set up primary keys. You set up relationships between the data. And then you go out building your database, right, in an exploratory way. To add more data, you just come in and hit Add Data Set. You have your choice of going to get more data from files. You can go define a SQL data set by making a SQL view over top of it. And then there's a bunch of guided transformations. This version only has union, but we're building out a whole bunch more. There's guided join, guided group bys, guided filters that help you build these things by point and click rather than having to know how to do SQL. Let's try one of these. So this is looking at data in my HDFS. And I want, this is that same file that we were just looking at. We can bring it in. It's tab delimited instead. You can pick up the field name. Since this file doesn't have field names in it, you can go grab a field name schema, attach it onto there, and continue editing, right? So you start bringing in more fields and taking a look as you go. All right. So once you have your data defined and you have your connections between them, actually, let's take a look at some connections. We don't need this. So the mentions table, so the export wanted all the events that happened. They're the original events of some occurrence of something that happened in the world. And the mentions are some other article talking about that event. And it can happen for years afterwards. And so this is the mentions table. It is, we go look at its relationships. It's related to the event table. That's called export. And it's related to some built-in date and time tables. It also, the other one, the event table has geolocations added onto it. You can see that. That one. So in this data, there were lat longs of where the things were occurring. Where was the person? Where was the other person? Where was the action going on? So these are lat longs that are in the data and a description of that location. So you can go about enriching the data, right? So this data catalog is the metastore on steroids, is how I like to describe it. It's everything that's in the metastore that says how to parse the data and how it's organized. But in addition, how does it relate to other data? How do you aggregate it? How do you want to add additional transformations to it? How do you relate it to other data sets? And so on. All right. Now that we've got some data defined, we can go make a lens. The way that you make a lens is you go to the data set that you want to build a lens on. And I've already made one over here. Let's take a look at this one. So the way that you build a lens is you just go to, and you go to a shopping cart experience. You go pick all the fields you want to put into this lens. Say, I want to break it. I want to break this thing down by this and that. In this case, I want to be able to break the data down by when it was mentioned, what type of mention it was, and it also goes off to the related data sets. So here we're going from our mentions to the actual events that occurred. And so the event occurred in a particular location. They talked about certain actors, et cetera, right? So you're able to, at this point, you're making a star schema for people that makes sense, right? So you're actually a snowflake schema. So you're going about and making a projection of all these tables and saying, I want all this stuff from here and all around it. And then we're going to hit a button, this build button at the bottom, and off goes the lens build. I'm not going to bother doing it because it takes a few minutes. But we can go look at the tracking page. There's other people using this system. So here is one of those lenses being built. So it goes through a whole bunch of tasks to go build the lens. So in our world, it's building dictionaries over distinct values of the data. I'll explain this in a second a little bit more. And a bunch of other steps that eventually gets you a database that's now in a much better form. That's what we call a lens. It's essentially just taking your data in raw form, transforming it so that you've done all of the transformation pipeline, and put it into nicer forms, right? So that it's nice and fast to use. Okay. Once you have your lens, you can make a visboard. And I made a little one. So here is An example visualization, you can make it by taking fields from over here and you drag them into different places over in these drop zones, we call them. And by doing that, you're making a query, right? You're essentially making an aggregation query that says how to, not just a query, but also a chart programming language, right? How do I want to build a chart. In this case, I wanted to build a bar chart that's showing % of total, broken out by whether or not Trump is in the URL. So what percentage of all the events that occurred, all the mentions that occurred in the United States and talked about Trump? Well, 12% of all the mentions that they found in the month that we're looking at, I think this is this past month, is 12.6% of those talked about Trump, right? So you can go about exploring this thing, and let's go do a little bit more. Let's take that out of color. And you see that it quickly updates. What do I want to have? I want to have country. If I can find it with looking over my shoulder. So this is kind of like backing up a trailer, you know? You got to turn the wrong way to make it go the right way. All right, country code. So this thing down here is the actor. This is like who was saying something about it. The police were saying something about it. And what were the country codes?
Put in details on it.
Well, thank you. Told you it's like I just hit the bushes. There. Okay. Now we get different country codes. So the United States is talking about the United States. That's not very interesting. But the police aren't talking about any country at all. I don't know this data very well, but you get the idea. So you're dragging and dropping, making different charts, right? As you put things in different places, you end up getting different experiences. So that's actor 2. Just a couple other quick charts. So each of these things, what's happening right now, when I clicked to this page, it just went off and generated a bunch of queries that went off to our query engine and interactively pulled all this data from the lens that we built and gave you this chart, right? So as you're moving things around, you're issuing more and more queries that go to this back end, and it runs an interactive query over the lens. All right, so here's a bunch of stuff over event codes. And you can also do some mapping. So this one's kind of fun. I defined a metric called Trumpiness, which says how much are they talking about Trump? And you can see, so the size is based upon Trumpiness. And so everyone that's talking about Trumpiness is like over in New York and DC, and big surprise in Russia and China. They're kind of interested about Trump too. All right. So that's platform. Any questions before I hop back into slide mode? Yeah.
How do you deal with caching and like automatically figuring out caching and how to optimize this so that caching is less of a problem? It seems like this is more of like a real time.
We once had a contest to count the number of caches in our system at different places. It was a really large number. I think we got up to around 30 for different types of things. But for the basic stuff, let's cover some of the most important ones. There is a query cache that says if someone's asking for the exact same query that I just saw, let's give them the answer right away. So there's a front door query cache that doesn't go through the engine at all except to check for permissions if it has to, right? If it misses on that, it's going to go run a query. That query has got the lens in a buffer pool. So I'm going to talk some more about the lens structure. It'll make a little more sense as I get through that. But essentially, we're keeping chunks of that lens go into memory and stay in memory. And so we find things really fast that way. And we do other tricks to replicate data across the cluster and keep it broadcasted. So I'll talk more about that in a second, too. It's a good question. And then there's a bunch of other caches for keeping directory listings and other stuff like that. Any other questions? All right, so that was all Plat 4, right? That was what we used to do. So Plat 4 has now become part of Workday. Workday bought us in August. And what does Workday do, if you don't know? Workday provides a unified HR and finance and planning applications and a bunch of other stuff as well. But those are sort of the major things that they sell. It's hosted in the cloud. Right? You buy their service, you run their HR system. Workday hosts it in their private cloud. Workday manages the two most important resources of some company. At least I think they're the most important: your people and your money. right? So if you have a business, you probably have both of those things, and they're both really important to you. So how does Plat 4 fit into that? It's kind of a question I asked when they were looking at buying us. You know, what do we have to do with HR or finance? So if you actually look inside of Workday, they have a bunch of analytics already. So everything that's in the pretty colors are things that are available today. They are doing financial consolidations. That's kind of a basic thing if you're doing finances, right? So lots of reports, your balance statements and all these things. And where Plat 4 comes in is in the next phase of it. It's in the next set of tools, which is to manage non-Workday data and do ad hoc visual analysis on top of the combined Workday data and external data. So what does that mean? So in a simple picture, you got Workday data. It has your HR records, or it has your finance data. It has all the events that are going on there. But your finance data only goes so deep. It doesn't have your cash register information in it. It doesn't have your website information in it. And so sometimes you want to explain, it's like that thing about every question turns into 5 more questions. You want to explain why your balance sheet is not looking the way you want it to. You might need some other data. Right? And so you want to bring those two things together. You want to be able to go from your balance sheet information and drill down to figuring out, okay, what were those expenses? Who's that person who keeps taking all those really expensive trips? Oh, that's why, right? And so you bring these two guys together and you start to get deeper insights. So for some examples of financial analytics, I like this one because it's easy to describe in Workday terms, profitability analysis. So you want to know, are you profitable or not? Well, your basic finance data will say, yes, you're profitable. Okay, can we break that down a little bit? Can you tell me if I'm profitable by customer? Which of my customers am I making a lot of money on? Which ones am I losing money on? How do I figure that out? If you look at Workday, they're running a whole bunch of services. Some of those services are shared services. Some of them are dedicated to certain customers. Some customers use a lot more services than others, and that's not reflected at all in your books, right? So you want to bring in together all your data center information and bring that together to make a model that says, okay, that's how much this customer cost me, and that's how much that customer cost me. And so there's a whole bunch of other financial applications that are along similar lines where you bring together your point of sale data with your finance data and get to some deeper insights. I think a big piece of it that Workday is also very interested in, everything that they have. They have your HR data and they have your finance data. Can you imagine stuff that's more secure than that? Maybe medical data. That's probably the only one I can think of where you start to get as paranoid. A lot of laws come into play. You have to be very careful not to release it. And if they leak it, that's a big problem for sales, right? So you need to have a really good security model built on top of this thing. And it has to be customized so that you can see your data and you can see your data and only the right stuff, right? So that means row-level security is coming into this picture. Same thing for people analytics. When I first thought about HR, I was like, okay, well, what does HR have to do with analytics? And I'm like, there's a whole bunch of them. You want to be monitoring your headcount and your turnover, your pipeline. So how is your recruiting doing? Which recruiters are working well for what fields, right? It's a lot of levels of information that you need to bring in extra information, right? So you're bringing stuff out of these other systems with the Workday data to get to a deeper understanding again. So at a real level, this is exactly what we were doing before, right? There's nothing different here. You're taking in a lot of data and merging it together in a tool that's easy to match the data together and coming up with deeper insights and then adding some more data and iterating. Okay, so somewhat to your question. This lens thing, I've now kind of dropped a level in technical difficulty of the talk. What is a lens? So let's take a simple example. We had like a little video view database that we loved to use for a really long time, sort of modeling Netflix or something. So you got some person watches a video on some device at some time, right? So that's all your events that are in there. And you go to Lens Builder, which we saw before. You pick some fields from each of these things and say, I'm interested in, what type of device, and I'm interested in the rating of the video, and I'm interested in the user's locations and overall time. So you pick a bunch of fields and you hit the build button, and you're going to get. I could have used a better example. So you get a query that's essentially conceptually being generated as a result of the lens request. The lens request is a group by query. A group by and join query. So it's going to join all those tables together in outer join. And run the group by, all the dimensions, and aggregate up on whatever you're trying to pick up here. So we're trying to figure out how many views were there, what was the average bit rate, how long did they watch it for, what was the duration, the total duration that they were watching. And we're going to break it out by user's age and gender, the video rating, device manufacturers, and month, right? So that's the request that goes off to the batch processing, and it goes and builds this lens. It's going to build this efficient structure that says, as long as you're interested in this space, we can answer your question really fast. You can't go everywhere in the world, but just to what you got ready and hot. And that's what this lens is all about. So this is that lens builder screen that's showing you all the steps. So what happens? The raw files go in, goes to this lens building process. It produces 3 major outputs. Dictionary files. So for every dimension, like gender or what else do we have in that thing? The ratings. There's a table that has all the distinct values. So we know exactly how many distinct values there are. Parquet does the same thing on a block-by-block basis, right? They will build a little dictionary, and then they use that dictionary to encode the rest more efficiently. Same idea, we make global dictionaries. Columnar files. Again, if you make an analogy to Parquet, sort of similar, which is we're going to take that data and we're going to not store it in row format, we're going to store it in column format. And we're going to make a whole bunch of partitions of that. And we build join indexes that help us connect the data sets together very fast. So you end up taking general joins and turn them into pointer joins, if that makes sense to you. So we're moving this lens builder from MapReduce into Spark SQL. We have a prototype of it. A lot of it is still in MapReduce, and because we have a whole slew of features that we built, and we need to reinvent them or make them better. So we have things like when new data arrives, do you have to build that entire thing all over again or not? We're smart about going, oh, no, I don't have to. I can make a really small little lens build that adds a delta to the previous lens. Or I don't need to do anything to that part of the lens because I already have that. I already have the date table built. I don't need to work on building that. I can share that from a previous lens. So that's reuse and incremental. We're smart about how we do our memory planning and join planning. So when we go do joins, we do broadcast joins, and we do repartition joins, same as Spark, right? But we sit there and worry about how much memory is this broadcast going to take, and can I pack it in? And if I can pack it into another job, I'll do more broadcasts on a later job. And what order to do them in, sort of. We don't do order that well, but we do the memory stuff really well. There's multi-versioned aspects to this. So there's a lens that's building. There's lenses that are being queried. We don't want to stop the queries while the lens is building. So we're managing these versions that are in there. And so on. A whole bunch of other features that have to get recreated. Maybe interesting ones to hit on is this event pattern matcher is a tool that we pull out of the shed quite often that lets us look over event data over time. So when you think about the mentions data, I want to figure out when was the same actor being talked about more than 4 times in a month, and I want to make a field about that. Let's use that for analysis, that sort of thing. Okay. So this lens, once it gets built, it gets loaded into the query engine. And this is now, to some degree, the caching stuff at some level. First, it's on disk, and then it gets pulled in as needed. And there's another level of detail to get to before I fully answer your question. So you got a bunch of workers. Those workers are going to get a bunch of data given to them. So you got a bunch of data that's broken into chunks. We call it blocks, chunks, whatever you want to call them. They are a bunch of rows, right? Let's say each of these gold boxes is 1 million rows. Tends to be our default. For dimensions, they're bigger. They get broadcast across the cluster. So you see that users is on all the nodes. But the views, which was the fact table, is getting partitioned across the nodes. So chunk 2 is only here and not any place else. There's actually replication in the system, but I took it out for simplicity. Okay, so each of these chunks is a bunch of rows. Those rows are columnar, right? So this is a bunch of column X, column Y, column Z, gender, age, whatever, month, are separate columns in each of these things and stored in columnar fashion. And so those columns, individual columns that are needed for the query, can be loaded into a buffer pool. So when the queries run, we don't have to load all this data to get started. We load up what's needed for that query, and that stays in. And it's quite often that people are picking fields that they might want. They love that. They love the add all button. Gives them all the fields, and then they don't query it. And so by pulling in the right pieces of that lens, it helps a lot. This will come up again. Okay, so we have this custom query engine that we built. We started, actually, I think it was 2011, if I do my math right, 5 years ago, over 5 years ago. we started building this thing. Spark was pretty young at that point. I knew Matei back in grad school, and I knew where that project was. It was a cool project, but it was younger. Hive was looking like it was falling apart when we started our project. Like the Hive teams were all going off to different companies, so it looked really shaky. This is just history. So we built our own. We built our own engine that was designed to do star schema queries really fast. That was its purpose in life. And so it takes these lenses and it knows how to read those lenses and process them. So we're now taking that engine, and we're taking a bunch of the technology out of that and trying to blend it into Spark SQL. So we want those two things to come together so we can share a whole bunch of what's going on in Spark SQL. Spark SQL's been getting so much better, so much faster. We want to keep riding that curve with it, right? So what are the types of things that we are putting into our version of our engine? Well, we need to work with our catalog, right? That fancy catalog with the Metastore on steroids. We need to be able to talk to that catalog and find data in there. Workday has their own data types. They've been around for 10 years. They have a data model. We have to support that data model. We don't get much choice in that, and I'll describe that in another slide. And from that, you get your own custom expressions, your own custom functions. Those have to kind of go with your custom data types. You have a security model. Workday has a very special security model. They have all kinds of fancy features in there. We need to support that, and it has to work in a way that's in the engine. And then a bunch of the things, so those are like what comes from the Workday part of this, and then what comes from the Platform side is a bunch of things out of the lens technology. So how do we take that lens format, the buffering, and bring that into our query processing in a way that we like? How do we keep that, the lens is this pipeline materialization, right, and efficient file formats. That's the essence. I don't care about the exact byte formats as much as I care about the concepts, right? Where we are broadcasting dimensions, typically, if they're small. If they get too big, then you start doing this co-located thing where you co-locate your fact with parts of your dimensions. That lets you get even bigger. You can play that game for so long before you're in trouble. But that's how you make a fast star engine. Column buffering, pointer joins, aggregations and view matching, query result caching, all these things are important bits that we have in this engine that we need to bring over to our new world. Okay, the Workday data model. I'm going to be brief here. Just the point that I want to make is Workday has an object. They have this object store that stores their transactions. It has a way of thinking about stuff. We're going to be taking that data into our world, and we have to take our version of Spark with it. And so some of the places where we get some fun is they have a numeric with a precision scale, and the precision is limited to like 200. Maybe that number got updated. 200 with a scale of 100. And Spark has decided to go 30, I think, 30. We have a currency type. A currency type is a numeric with a unit. That can be stored there. Or optionally, it can be a currency type that knows its unit, but we have to remember that in the type. So that as we do type propagation, we can tell you, oh, that sum is a sum of dollars, not a sum of yens, right? Daytime zones. And then the place where it also gets really pretty interesting is it's an object model. They have pointers between their objects. We need to bring those pointers along to our world and hand them back to other parts of Workday. So we have this, await is a Workday ID type. It's a UUID that we need to carry around and play with. And we need to know that that's an ID of a particular type of object. This is an ID of a worker. This is an ID of a location, so that we can talk to other systems with those types. Okay. There's a security model. I'm just going to be very brief because I'm running out of time. There's a bunch of levels of scope, right? So there's cell level security. You can talk about this column and this row. It gets connected into, every row knows its relationship to things like a department or a location. And then users that come to read data know what they manage. The system knows what you manage. You manage this department or you work in this location. And that's used to filter the data, right? So that's a really important part of making this thing work within Workday. Something we didn't have to do in Platform. Okay, so now I'm going to go one more level down in technical depth. I'm going to try to do some performance results. I think these are pretty interesting. I'm going to do them in 7 minutes. So hold on to your seats. Okay, so a really simple star join experiment. Okay, I've got a fact table and a dimension table. The dimension table in the experiment, it's going to be increasing in size from 2 rows to 400 million rows or something like that. Okay, so dimension gets bigger and bigger. So it's this query. We're doing a join of the fact and some dimension, which is going to be varying in size. It's a foreign key-to-key join. And we're going to group by a column which has cardinality 2, right? So the result of this query is always 2 rows, sometimes 1. But it has to do a big join in the middle, right? OK, so I think we covered all of that stuff. Yeah. All right. So we're going to compare a bunch of different storage formats and their join plans, scan and join plans. We're running on 3 executors that had 170 gigabytes of RAM and 16 cores each, right? So 3 times 170, 3 times 16 cores. Sort of a standard reasonable configuration for one customer to have. OK, so we looked at 4 major types of data and the corresponding plans. So we took the data, put it in Parquet format, and said, OK, put it in Parquet, run the joins, and do the aggregation on top of that. Let's see how that behaves as a good baseline. It's a nice storage format. We're not doing something stupid with CSVs. Let's try using the cache. So take those Parquets, put them in Spark's cache, do the same thing. It still has to do the joins because the joins are coming after the caching, right? Check out our lens format that we've integrated with Spark SQL. So we have this lens running in Spark that actually injects into each executor a buffer pool that has these column files in it. It understands collocation and how it's placed things. It understands that it's broadcasted some stuff. It understands that some stuff's partitioned and living on certain nodes. And that join, and so there's no more join because it's going to be pre-joined essentially. There's a join, it's a funny join, it's a pointer join. So that's what I'm trying to express here, and I'll describe it one more time in a second. But we're going to have to go from a few columns, but it's not a full-fledged join. We know that the data is local, we know that we can find it in buffer pools, and we know that we're following pointers to get there. Okay? And the last one is we're going to take it and we're going to do a pre-join into Parquet. So run the join, build a Parquet table, and take a look at that one. So there's no more join in the queries, but guess what? It blows up pretty bad because you're taking all the dimensions and replicating them out, right? The lens exactly doesn't do that. It keeps things normalized, so you have dimensions that are not being replicated. But the price you pay is additional join, hidden. Okay, so you can see some of the data sizes and other stuff. I won't belabor it, but you can see that the Parquet is nearly a terabyte, where we're starting at 180, 150 gigabytes. So it's a lot bigger. Just to reiterate the lens structure one more time, so you have a bunch of blocks that are in the fact table. These things are all a million rows long. They're pointing at the dimension table. The dimension table is varying in size from 2 rows to 400 million. And then they're all pointing at this dictionary of 2 values. Okay? So when we go scanning, we have a bunch of threads that are going to scan these things. They're going to follow their pointers, do a join over from here to here. From there, do a join to go pick up their values. And then you can do the group by. All right, so let's first look at Parquet versus cached. So Parquet data sets being joined and the cache data being joined. So how much did caching help out? There's a little bit of variation up here that I need to sort out. Take it with a grain of salt, exactly where that lands. But you see the trend line. And what happens in this jump is exactly where Parquet could no longer do broadcast joins. I tried to make it do a broadcast join, and it tried. And it said, because it hit 1 gigabyte limit trying to broadcast something bigger than 1 gigabyte. I can't do it. I give up. Try something else. So I had to tell it, don't do that. Do a sort merge join instead, or just don't broadcast. And it chose sort merge join, and that came up here. Okay, so that's this big jump. Down here, you see that it actually runs pretty well. Looks pretty good. Caching helped some, and if we zoomed in, it would help more. Right? It's being kind of dwarfed by magnitude of what happens later. The red line said, well, I tried to guess if I'm on this blue line and I could keep broadcasting, what would happen? And I tried to guess what that would be. It's my best fit. But the point is, eventually you're going to want to do a sort merge join. You can't keep broadcasting forever because the cost of broadcasting starts to outweigh the repartitioning, right? So when does that happen? It depends on the exact query you're running. The left column is milliseconds, if you're wondering. The x-axis is the size of that dimension table, if that wasn't clear. Okay, so let's take the Parquet, that same line we're looking at a second ago, and compare it against pre-joined. So we make a pre-joined Parquet file, or do the join on the non-joined Parquet files. So the non-joined looks pretty good as long as it stays small, and when it switches over to that other join strategy, not so good, and the pre-joined looks better. Right? That makes some sense. We tossed it our lens, and it ends up down here and saying, okay, good, I can keep running. I start to pay a little bit for the increase in dimensionality, but because it's broadcast, I don't pay nearly as badly, right? So that was great. I was happy. That was Friday. I went home for the weekend going, all right, got a good talk. Everything's looking pretty good. By the way, we haven't optimized this code much yet, right? So it was a little bit of a sweat for me over the past couple of weeks. But I was really happy, and then I wasn't fully happy. I went and looked at this and said, but why is that thing so slow? It should be faster. It's running a whole bunch of partitions. It runs 7,000 tasks to get its job done. Because what happens? Because the table's getting really wide, the table has some 300 odd columns, or maybe 400, the Parquet blocks get less and less rows in them. And so you end up with these little fragments of stuff to go read, right? That's what's happening in here. And if you add more columns, it's just going to get worse. But I said, well, what if we increase the block size? How big can I make it? I tried really hard to make a 2 gig block size. I finally succeeded. It took me until Sunday to make that happen. And this happened, and I was really shocked. On Sunday evening, I started getting numbers that said, hey, this pre-join thing actually can work really well. So that's interesting, but you have to get really big block sizes, right? So the other one's up here, right? So what do we take away from that? Well, a number of things. I think there's a bunch of interesting stuff in here. So this is the lens, zoomed in. Now we're kind of looking at more reasonable timescales, a couple of seconds. And this thing, the join stuff is always going to be a flat line because it's always doing the same thing. It's always going to pick up a column that has 2 values in it and do a group by on it. It just has to do with how does it find it in the Parquet file. That's the difference in the experiments. Here, we have to do joins of the bigger and bigger arrays, right? And so when I first had these numbers on the previous day, this was, I go, oh, that must be when I hit the L1, L2, L3 caches and things start to go bad. Then we start hitting memory latencies at this point. So I wrote a little test program that I made it go do kind of the same thing, but without any extra Spark stuff around, and just focused in on the arrays, and I'm down here. So something else is happening that I don't yet have an explanation. So why is this thing going up, and why is it up here? Both of those, I think, are unexplained things to go, that's future work for our team to go figure out. And I think it is CodeGen. So to test that theory a little bit, I said, okay, if it's CodeGen, why don't we try turning off that new vectorization code? Whoever wrote that, if you're here, and you did a good job. So this is the same file here being run without the vectorized CodeGen on it. So you get a nice factor of 4 improvement just by turning on this better code generation code, right? Nothing else going on there than better generated code. So I think there's a good chance that this thing comes down once we get into figuring out what's going on with CodeGen. All right. The other thing that this is also an interesting question. We spent a lot of time wondering about it. This is the pre-joined with 128 megabyte block sizes. This is the 2 gig block sizes. Why is there a 17 times difference between these two? It seems to have something to do with the size of the row groups. That seems to be that's the only variable in here. And so I guess it's probably to do with there's 21,000 tasks or 21,000 blocks being put into 7,200 tasks instead of 448 blocks being put into 224 blocks. That's probably the answer. But I don't know. That's another mystery that needs a little bit more investigation. Interestingly, so going back to the Parquet numbers, it's hiding in here. I think I had it over here too. Yeah, this is interesting. So why is this guy so far down here? Like, it's pretty amazing. It's reading stuff from disk, from HDFS, for God's sake, right? And decoding it, and doing that faster than we were finding stuff in memory. Like, there's clearly something wrong with this picture, right? At least to me. So what else is going on? Well, one of the answers is, this is kind of a best case results. Parquet is picking up really tiny columns of 2 values each. They take 1 bit each, 1 bit per row. That's how small that stuff is, because they just found, well, it's A or B, right? Okay. Write down bit vectors, that's the answer. So they write down a bunch of bit vectors, and they'd have to decode them and run on them, right? So expect this thing to go up if you try to repeat this experiment. If you start changing the number of columns or the sizes of the columns, you're going to see a definite increase in this thing. You'll see some increase on this one too, of course. But your mileage may vary in this result. All right. Wrapping up. So problems that we hit a whole bunch of problems while trying to run these experiments. Thought I'd cover some that are interesting. Node locality doesn't get properly recognized for some reason. Like Spark says, no, you're not node local, but you are. I've fully replicated my file everywhere in every node, and it doesn't find it. Maybe something to do with name node giving IP addresses and names. I don't know, something weird. But that caused a problem with some of the jobs sitting there waiting for their 3 seconds to do nothing, waiting for an executor who might never arrive. And so I had to set that down to 0, which causes it to run non-local, right? So that was happening in the Spark jobs. The Parquet jobs. The cache ends up getting imbalanced. So when you do caching, they did not get even numbers of bytes in each of the caches. And that continues to pollute you for the rest of the time. Once you get imbalanced cache, every query you do on that cache is skewed, right? Probably related to number 1. I don't know. There might be another problem. Over and under partitioning, because partitioning is not being chosen in any smart way, you have to manually tune it, and that's your only choice. And if you go too many partitions, it runs slow, much slower than needed. If you go too small, things start failing. Broadcasting configuration limits are not quite, they're respected, but if you go too high, it ends up just failing the jobs. It doesn't actually plan it correctly. So you have to manually tune some of that stuff. You can read the rest of these guys, just to move on for time. Okay, so conclusions. I think Spark SQL is a great base for Workday Analytics and what we did at Plef4. I think we're having a lot of success moving stuff in there, and it's very flexible code base, can do a lot of good stuff in there. We have to do a bunch of big extensions for our needs, and some of that is really easy and good. There's nice APIs to plug in your own catalog. That's awesome. You can put your own parser on top. They don't seem to mind that. But there's some exceptions. Like data type extensibility is not fully baked. As a matter of fact, it's gone in Spark 2.0, got pushed into private. You're not even supposed to be using it. Of course, I always violate these things by finding either package violations or reflection violations to make it work. So that's how we're getting our own data type extensibility, but it'd be nice to be doing it the right way. So I'd love to talk to people that are interested in that. Once you start doing that, you have to start doing things like your own rules around type promotion and things like that. So you end up in the rewrite engine, want to take control over some of those rules and have them configurable based upon your extensions. So I think there's a lot to do there. The early lens results were promising. I was really happy with the first numbers until Sunday. I'm still pretty happy. I think as we dig into it a little deeper, we'll get some better results. And as Mike said, we're hiring. It's up here. Oops, too fast. If you're looking for a job, we're looking for you. All kinds of people around here from Workday. Talk to them. Any questions?
Thank you, Kevin. Guys, have any questions? We've got a couple of minutes before we got started with the next one. Any questions?
So the extensions you think you need to make to Spark SQL, how general? Do you think somebody besides Workday will actually use them?
Some of them. So I think the extension points would get used. The extension that we do, likely not, right? Like our type system is our type system. You don't have WIDs, you probably don't care about them.
Increase the precision, for example, and then, you know.
That was an interesting one. The precision one used to be unlimited, and then it got changed to be Hive compatible, I think, and made it 30, or maybe Parquet compatible. I don't know. Some reason. I'm sure there's a reason that there's something else that has a limit on it. Who on God's earth needs more than 30 digits? I don't know, but Workday has 200 of them. So I got to figure out a solution. So if that's configurable, that'd be great. Set and say that's how it works. But I think a lot of them would be custom. But having the points, so like having the UDT stuff get worked out in a way that makes sense, that we could all enjoy, that I think makes a lot of sense. So I'd like to work on that as a collaborative thing. Way in high rise, nosebleeds.
So in the lens mechanism, does it allow like incremental update if you add documents?
It does with the asterisk on the, it does. So is a lens be maintained? Can you take in new data and add to the lens? Yes, we have a bunch of smarts in our current lens builder that does that. It sees that there's new data and it sees what the lens definition is. And if you haven't used hard features, then it's incrementally maintainable, right? So if you're doing the wrong thing, then it can't be. If you change a dimension, that's kind of a bad thing. It can cause all kinds of stuff to get, if you like, if you're essentially causing edits in the past, that's going to cause trouble. Any other questions?